number 9. Put an equilateral here. Let's have an equilateral. So this would be A, B, C. A is here. A, B, C. And then you have, let's put it here. So an isosceles triangle, right, like that. We put D here. So we're going to try to prove that this line, the length of this line equals that line, right? So we want to prove AD equals BC. So this side equals that side, and all these three sides are equal. All right. So if I so here's how we can prove it. If I pick the midpoint of this line and label it as M, then I can connect this point with this line. So right now, do I know if M, A, D are on the same line? They are, but I don't know yet.
Yeah.
Okay, we can prove that they're on the same line, right? So because I connected A and D first, and then I connected A and M, or our intuition tells us that they are on the same line, but it's still, you still want to prove it, right? So how do you prove that? These 3 points are on the same line.
Well, it's an equilateral triangle.
Uh-huh.
So if you made a midpoint between B and C, then the line going up would be perpendicular.
Well, because that's true
Yeah,
for
so this is-
collateral and isosceles,
Yeah.
and they're both nations in
Yeah.
base, so.
Yeah, right, so this is midpoint, this point, so that for this isosceles triangle, no, this is the equilateral triangle, this line AM is perpendicular to BC, right? And for the isosceles triangle, we can ignore DA and AM, just draw a line straight from D to M.
Yeah.
That's another line, right? That line would be perpendicular to BC as well, right? So through the same point, you only have one line that's perpendicular to BC, so that they're the same line, right? So that these 3 points are on the same line. So once that's proved, we can chase the angles, because angle D equals half of angle BAC, right? Well, let us make this as 1. And because angle 1 is half of angle BAC, that we can prove, right? Because that's half of it. So angle 1 actually equals angle D. Right? And from here, we have angle, well, label this as 2, label this as 3. So I'm trying to prove that angle 2 equals to angle 3. So angle 1 equals angle 2 plus angle 3, right? And that means angle D is also equal to angle 2 plus angle 3. So this is also equal to these two triangles, right? And because this is angle D equals 2 times angle 2, right? So if you let this equal to that, well, I just write it as 2 times angle 2 equals angle 2 plus angle 3, and I cancel one of them, so it says angle 2 equals angle 3, right? So that way this is an isosceles triangle, so from here we get AD equals AC,
Yeah,
and this is the equilateral, so that AD is also equal to BC. Right, that's proof.